So I will continue the discussion on the Feynman machine. As I told you guys yesterday, for today, we will continue with some other problem example, and maybe 3 to 4 problem example. Okay, and then I will give you some homework. And for next week, right? Thursday next week, we will start the class with the quiz. Okay, we will start our class with quiz on the Feynman machine. Okay, and then we will continue the discussion on the Feynman machine to finish all the things that you have to know about Feynman machine. Okay, so basically, today we will do a practice session. I will give you several problem example. There will be a homework as well about the Feynman machine. Then next week, you have a quiz on the Feynman machine. Okay, I believe it's supposed to be clear enough. And I think I want to start the discussion on this particular problem. Okay. Anyone knows what is this? Actually, it's quite clear. It's stated here. Okay. It's some kind of device to increase the oil pressure. Okay. So basically, how the device works is by giving a force like this, then the piston here will move down to help to increase the pressure like that. Okay, so that's the device. That's how the device works. So basically, there is a ring rod like this, long ring rod like that, and we can add a force P there, and then at point C, the long link there is connected to this particular piston, and that particular pistons can move up and down based on the force given. Okay, in this particular things, because the force is going down, so it will be moving down as well. Okay, it will be moving down as well. Okay, anyone still having a problem understanding this particular example? Adiatma Dipa. Do you understand about this?
A little bit, sir.
Okay. How about you, Sunita? Hello, Sunita? Don't say that you sleep again, Sunita. No, right? Hello, Sunita? Okay, Sunita is not around. Why there are so many of you who where I call? Okay. Okay, Noki. You can restart your device.
Excuse me, sir.
Yep.
Could you repeat the middle part of your explanation?
Oh, Marsha. So basically, what I asked you about is whether you understand about this particular problem or not. So basically, this device is used to increase the pressure. How it can increase the pressure is by giving a force P there, and because we give a force P there, so the long link, this one, that one, will move down at this particular part, right? It will move down like this. While it's moving down, it will push this particular link down as well, where it has a piston there. So it means that when it's moving down, when the force P is given, the piston will move down as well. Well, the piston is moving down. It will increase the pressure. So that's how the device works. Do you understand?
Yes, sir.
Okay. So the question here is, the angle theta there is 15 degrees. Okay, the angle theta there is 15 degrees. Here, it's 15 degrees. When the P is equal to 120 Newton, okay, determine the oil pressure P, which acts on the 46 millimeter diameter piston there. So what is the oil pressure here, which is happening here at this particular piston? And that particular piston has an area with 46 millimeter diameter. So the diameter equal to 46 millimeter. Okay. Anyone here have any idea on how to do this? Anyone here have any idea on how to do this? Johan?
Yes, sir.
Yeah. Do you have any idea on how to do this, Johan?
I think we first draw the free body diagram.
Draw the free body diagram of what?
The lever, I mean the AC and
The long one.
Yeah, the long one.
Okay. Okay, but before that, the one in question is the oil pressure P, which acts on the 46 millimeter diameter piston. So basically, the one that we're supposed to find is what? In order to find that, Johan?
The force going upwards at C, I think.
Okay, yes, you are correct. So basically, the force which is happening at the piston, actually, right? The force which is happening at the piston and the pressure there, actually, basically, we can the pressure that is supposed to be happening there is supposed to be the force divided by A. Where A is the cross-sectional area. Okay. Okay, so the pressure is there supposed to be force divided by A. A there is supposed to be pi multiplied by d squared divided by 4. Like that. Okay, so that's how we calculate the pressure. Okay, that's how we calculate the pressure. Okay, and in order to find this particular pressure, so what we have to find first is the force which is happening at the piston. Okay, the force which is happening at the piston. How can we find that? Okay, how can we find that? Actually, we can find it by calculating the force which is happening at this particular pin. Okay, which is happening at the particular pin. That's all. Okay, but before that, in order to solve it, then one thing that you're supposed to solve is the free body diagram. In order to find out the force which is happening at this particular pin, okay, which free body diagram that you're supposed to draw. So based on Johan's explanation just now, we're supposed to draw this this particular member free body diagram. Correct, Johan?
Yes, sir.
Yeah. Okay, so let's try to do that. So this is the member. And at point C, there is a joint there. And we have force P here. Sorry, the force P is 120 Newton. I put it 120 Newton there. Then at point C there, it's supposed to be. Okay, Johan, would you mind to help me to solve this particular problem? At point C and at point A, what kind of force they are supposed to give there?
I think there are on point C there are Cx and Cy.
Why?
Because the lever, I mean the pump is not parallel to the x-axis, so
Mm-hmm.
the-
Actually,
and-
the reason is not like that, because one of the main reason here is the there is a joint there, there is a pin there, right?
yes, sir.
Okay, there is a pin there, and beside that, we are not that sure that the piston, the link, the member for the pistons, is actually two force member or not. We are not sure about that, right? Okay, if we are not sure about that, then we have to assume it as non-two force member, Cy, Cx, like that. Okay, and how about at point A, Johan?
I think the same applies. So
Are you sure? Take a look at AB. What do you think about a member AB? Remember the first
two force
rule.
member.
Yeah, correct. You guys need to remember that the first rule to solve for frame and machine problem is to find out which one is the two force member, because by finding out the two force member, you can simplify the problem. How to simplify it? If AB is not assumed as two force member, then you have to do it this way: AY, AX. Okay, take a look at the this particular free body diagram. We have four unknowns, and the number of equation that we have is only three. Sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. We cannot solve it. Okay, but if from the beginning we analyze the holdings and we know that the AB member AB is two force member, then our free body diagram become like this. Okay, and 20 Newton there. Sorry. Then at point C, Cx and Cy. at point A, because I know that AB is non-two-force member, then I can do it this way. FAB. What's the difference between these two? Okay, the first one, we have 4 unknowns, but here we only have 3 unknowns, and say we have 3 equations. Okay, this one is solvable, but this one is not solvable. Do you get it, guys? That's the importance of finding the two-force member at the beginning of frame or machine analysis. Is it understood, Johan?
Yes, sir, I understand.
Good.
Sir,
Can we,
then,
can we solve it, Johan?
Yes, I think, yeah, we can.
Okay. Yes, Asya. Do you want to say something, Asya?
would the FAB fall under FX or FY?
Sorry. FAB direction is X or Y. Oh, what do you mean by that?
In our calculation soon, would we consider FAB as in the FX equation, sigma FX equation, or the sigma FY equation?
Yeah, of course, on both then. Because there is an angle here, Azar. Right? There is an angle there. So there is an X component and Y component for sigma FAB there. Do you get it, Azar? Hello, sir?
Then how would that be different from AX and AY?
AX and AY. No. Something like this. AX and AY here, if you do it this way, there are 2 unknowns, Azar. AB is only 1 unknown because the angle, the direction of the force is known based on the direction of this particular link, AB link here. Okay, so this is the line of action of FAB. Okay, knowing the angle, knowing the direction is producing 1 unknowns. I said, why? Because now the unknown is only FAB. If it's like this, okay, it means that we don't know the direction yet. So we like it or not, we have to replace it with 2 unknowns. Do you get it, Asad?
Also, the force at A and force A, the one on the left free body diagram and the right free body diagram are 2 different forces then.
The left one actually is the same forces, but if we put it on like the left one, we cannot solve it. But if you do it like the right one, you will be able to solve it. So basically, AX and AY will represent FAB as well. But unfortunately for us, if we do it this way, on like the one on the left, okay, we will not be able to solve it. And it is not right as well, because by doing like this, AX and AY like this, it means that we don't know the direction from the beginning. That's why we give 2 unknowns there, AX and AY. Because AX and AY it can be anything. But if we do it this way, okay, the direction is there already. So it's only 1 unknowns at a particular point. Do you get it, Asad?
Okay, sir.
Yep. So basically, I think I will try to explain a little bit on your question just now. Okay, so basically, this is what that's my our previous problem: 120 newtons, CX,
Sir,
CY.
I want to ask.
Oh, wait a minute. I think I will
Okay.
explain a little bit about this.
Oh,
AY,
okay, sir.
AX. Okay. Okay, Azar. So basically, if we draw it this way, the meaning behind that is actually later, okay, at that particular point, okay, at this particular point, right? Okay, the one that we don't know is the magnitude of the force. If you just want to represent it with the one force only, so this FA here, we don't know the magnitude, okay? And here, the direction theta A, we don't know the theta as well. Do you get it, Asya?
Yes.
So basically, if we do a factor summation of AX and AY, what we get is will be FA like this, right?
Yes, sir.
Yeah, but the problem is, FA here, we don't know the magnitude and we don't know the direction as well. So the direction can be like this, or it can be like this, or it can be like this. That's why we represent it with two unknowns here, AX and AY, to represent the unknowns here, the magnitude and the direction. Do you get it? So actually at point A here, the unknowns is the magnitude and the direction of the total factors of force which is happening at point A. Do you get it? That's it.
Yes, sir, so far.
So basically this and this we can sum it, and the result will be FA, and the direction we still not yet know. The magnitude we still not yet know. That's the meaning of having two unknowns like this. But okay, I said, if we do it like this, the one on the right, okay, the magnitude is not yet known, but the direction is already known. The theta there is known. How can we know the theta? Because we know that this is two force member with certain angle here. Do you get it, Asir? So the number of unknown here is just one actually. That's why we cannot represent it as AX and AY. Do you get it, Asir?
Yes, sir.
Yeah. So that's the thing. So when it's a two force member, okay, the good thing about two force member is the direction will be there, because the direction will be the same as the alignment of the link of the member like this. So this will be the line of action. Okay, so we do not need to put it as AX, AY like this, because we will add an unknowns that is not supposed to be there. Okay, so the correct free-body diagram is like this. Okay.
Hello, sir.
Who's this? Matthew. Yes. Matthew.
Are you assuming CY and CX because you don't know the angle?
I'm assuming CY and CX because what?
Because we cannot determine the angle.
Yep, correct. Because I'm not sure whether it's two force member or not, because there is a piston there. If there is a piston there, there is high possibility that there will be a normal in that direction there. Right? So most likely, this particular member is not two force member. If that particular member is not two force member, I cannot assume. I cannot assume at point C only one force that I'm supposed to draw it there. No, I cannot. So I have to draw it as CX and CY. Do you get it, Matthew?
Because I was thinking about assuming the x-axis is by the line AP. So that-
x-axis by
Yeah,
the
so that
length.
we can determine the angle of
Hmm,
C.
angle of C. Okay.
Yes.
Uh,
so
there
angle
is
of
one,
C must
one-
be
There is one drawback there because the direction that the direction that will give pressure is the y direction that I draw here. So vertical, correct?
Oh, yes, sir.
That's why I draw it this way, because I want to know this cy. Okay, if you draw it like this with this particular axis, right, x and y, yes, later you will find x and y much easier, but there is one drawback there. In order to find the force in the direction of the piston movement, okay, you have to do a vector calculation again. Do you get it, Matthew?
So we have to find C in terms of
CY.
Y only.
Yeah, cy. Why we need to find a cx?
Oh,
The one that will give you the pressure is cy, right?
okay, sir. So don't get why C is not a two-force member.
C is not two force member. C is not two force member because, okay, let me draw. Let me draw it here. If this is the pistons, right? Let me draw it. I assume that the piston shape is like this. Okay. So let's draw the free body diagram of the pistons. Okay. When you take a look at a piston, okay, when you see a pistons, right? What will happen at this particular area, Matthew? There will be a friction there, right? Correct.
Yes, sir.
Okay, and there will be a contact there as well with the cylinder block, right? Between the piston and the cylinder block, between the piston and these particular things. Correct or not?
Yes, sir.
So I don't know what forces which will be happening here. Okay, and most likely it will be there. So like it or not, I cannot assume this as two force member. Do you get that? So later, there will be a pressure in here, and there will be a pressure here as well. Okay, and later here, it can be like this. Cx, cy, cx. Okay, cy is supposed to be going. Okay, because I don't know whether these particle force are exactly the same or not, right? For sure, we cannot assume this as two force member, because two force member, the meaning of two force member is just a member which either under compression or under tension. Do you get it, Matthew?
Yes, sir. But I thought it'll be the same yang ke kiri and kanan. Karena
Then if it's still the same as well, but the moment can happen there. So it's not necessarily can be a two force member. Two force member, when you want to assume it as two force member, then it must be it must be clear that it's two force member.
I see now, sir.
So like AB is clear that it's two force member. Okay. Without assuming it as a two force member, we still can solve it. You can see that CY, CX, FAB, we have three unknowns. We have sigma FX, sigma FY, sigma moment, and we still can solve it, right? Now, oh, just now the one who helps me was Johan. Okay, Johan, would you mind to point out one of your friend to help me to solve for this particular problem, CY, to find CY.
Okay.
Who, Johan?
Yes, sir. Wait, I am looking for someone. I think Jovan.
Jovan. Okay, Jovan, would you mind to help me?
Sure, sir.
Okay, Jovan, let us calculate for CY. How can we, where we supposed to start, Jovan?
FY?
Sigma Fy. Actually, yeah, you can, but you can, but
Moment
you
first,
will.
I mean.
Yes, correct. Sigma moment, which particular point?
At A.
At A, you will not be able to solve it directly as well, because Cx and Cy will give a moment there. So actually, this is what you're supposed to do, okay? Although you still can do it that way, but it will be much more effective if you start with this sigma moment at point C equal to 0. By doing so, you will be able to find FAB.
Oh, okay.
Okay, sigma moment okay at point C equal to 0. Okay, what we have there, we have 40 millimeters to 100 millimeters. Okay, so basically after that you have to find out the angle of the link AB there, right? Theta there. As long as you find out theta, you will be able to find AB. Okay, do you get it?
Yeah.
Okay, and that's the first thing that you're supposed to do. Then after that, you can use sigma fx and sigma fy to solve for cx and cy. Okay, Jovan.
Yes.
That's the sequence that we're supposed to do. And but the problem here, I believe some of you will have a problem in finding theta there. Sorry, not theta here, yeah. Okay, this one is not supposed to be theta, alpha. Okay, alpha there. This one, alpha. What is the angle between link AB and link AC? Can you help me to find out that? As long as you can find that, it will be quite easy.
Is it sin 80 over 200?
Sin 80? Why suddenly sin 80?
Because the distance is 80.
No. You have to draw it first. Theta there is 15 degrees, right? So this is the things that you're supposed to draw. This is 15 degrees. What else there? There is an angle, say 80 millimeters, 200 millimeters, 40 millimeters. Then we have 200 millimeters. Then after that, Here is 40 millimeters. Is it the correct dimension or? Correct, right?
Oh, I didn't see the 40. Yeah.
Yes, there's 40 there. Okay, but the one that we need is this particular angle between this particular angle alpha. That's the one we need, right?
Yeah.
Okay, so how can we get it?
Can I see the question again, sir?
I draw it for you there for you to solve. Actually, this one, you just need to solve for this one. 200 millimeters, 80 millimeters, and 40 millimeters there.
Is it cos 15
sir.
times 80 minus 40 over 200?
Sorry?
Cos 15 times 80.
Okay. Cos 15 times 80. So basically, this is what you are trying to get. So this particular distance, right?
Wait, no. Oh, yes.
Yeah, correct, right?
Yes.
This particular distance is cos 15 times 80, then minus 40. So this is what you will get. Cos 15 times 80 minus 40 is this one, right?
Yes.
That one. Then
over 200.
Over 200. What will you get at?
The arcsin.
Nope, it's not alpha, but it's beta here.
Yeah, it's the same with alpha, sir.
Are you sure? Is it the same?
Alpha?
Is it the same with alpha, beta? Sorry, that's angle is like that, and this is, we have 15 degrees there. Degrees. Are you sure it's the same? How can you say that it's the same?
Sir, why is alpha perpendicular to AC? I mean, yeah, like that.
Yeah. Alpha is perpendicular to AC.
Yes,
no,
sir.
I mean,
Why?
Why? Why alpha is perpendicular to AC? Yeah, actually, you can find any angle that you want, but I put alpha perpendicular to AC in order to, or else, okay, you want alpha to be vertical like that, right? So just use beta then. You mean like that?
Yeah, just use beta, sir. I was thinking like that.
Yes, you can do it that way. We can just use beta, but when somebody say that alpha and beta is the same, no, alpha and beta is not the same. So we can just use beta here. This is beta.
Oh, I see. Yeah.
Okay, Jovan, do you get it, Jovan? So
yes,
you were going the right direction, but alpha and beta is not the same.
Yeah. Okay.
So basically, just now I will explain again what Jovan trying to do right now. Right. This is the one. This is you who give me the idea, right?
Yes, sir.
Okay. So basically, what Jovan is trying to do is to find out the horizontal distance of the 80 millimeters. So 80 millimeters cos 15 degrees. So it will be this particular distance. Okay. Then after that, he minus it with this 40 millimeters minus 40 millimeters. So it become this particular distance. Okay. And then we have the 200 millimeters there, right? We have the 200 millimeters there. So if I name this as X, well, this, right? So beta will be X divided by X divided by 200, okay, 200 millimeters. So it will be sin beta, right? Correct lah, Jovan? It's sin beta, right?
Yes, it's in.
Okay, sin beta is equal to X divided by 200 millimeter, where X is like this. So if you want to find out what is the value of beta, so you can just find arcus arcsin of this particular value. So you will be able to find beta. Okay, thank you, Jovan. Okay, after we find out for beta, we can calculate for the moment. Okay, we can calculate for the moment, and then we can finish for the calculation of the Cx and Cy. So FAB will be known by calculating the moment at C, then Cx and Cy will be solved as well. Okay, it's supposed to be clear enough there. Okay, any question about this particular problem before I'm moving out to the next one?
May I see the next slide again, sir? This one. Wait.
Sir, what are you trying to do with alpha?
Actually, it's just the same as beta. By finding alpha, you will be doing well. By finding alpha, you can calculate for the moment as well.
Is it so that you don't have to find the angle for P?
Yes, most actually yes. I prefer to actually beta and alpha is just the same. Actually, not just the same, but I mean beta is actually alpha minus theta, right? So it's basically like that. Okay, beta is just beta is actually alpha minus 15 degrees. So basically, by doing so, I can calculate for the moment directly without doing any modification there. Okay, because all the angle there, sorry, all the distance there is in the alignment of AC. Right?
Oh,
that's why I want to find alpha instead of beta. But actually, it's just the same. After you find out for beta, then you can solve for alpha by beta plus 15 degrees. It will be alpha.
But then you use beta when finding Cy.
Cy? Yes. Yeah. As I told you, alpha and beta. Actually, you can find alpha from beta, beta from alpha. Right?
Okay, thank you, sir.
Any other question about this?
So, sir, do we use beta or we use beta as a means to find alpha?
We can use beta. We can use beta as a means to find alpha as well. So both you can use both. Okay, sir. Because by using beta only, yes, you can do everything. But by using alpha later, in order to calculate for Cx and Cy, you can calculate for beta as well by beta is equal to alpha minus 50 degrees. Okay, so the problem here is the angle is slightly complicated. That's why you have to find the angle first. Sometimes when we have a frame problem like this, those problems will appear. So the geometry will be more complicated than the calculation of the forces. Sometimes it's like that. Okay, sir.
Okay, sir.
Both are in connection. So alpha and beta is in connection. So you don't have to worry about it. Okay, in that case, I think I will continue with this one or this one. Wait a minute. I think I will start with this. 2 years ago, I put this as the quiz in the class, but let's try it here. Okay, if you are confused about the LBF and inches there, you can just replace all the inches there with you can replace all the inches there with centimeters and the pound there with Newton like that. Okay, the calculation will be the same. So basically, actually, the calculation will not be the same, but basically, I just want to give you guys the concepts about how to solve this. That's all. Just now, the one who helps me was Johan and Jovan, right? Okay, Jovan, now please help me to find to pick one of your female friends, Jovan.
Okay, hold on, sir. Michelle, sir.
Michelle. Hello, Michelle.
Yes, sir.
Wait. Have you helped me yesterday as well, Michelle?
No, sir.
Oh, not yet. Okay then. So, I need your help to solve for this, Michelle.
Okay, sir.
Okay, but do you understand completely the whole problem or not?
This question?
Yep.
Maybe.
Yeah. So basically, it's kind of we call this as a lifting tongs. So this particular device will grab things at this end and this end, and using the frictional force there, it will lift the crates here, and it's known that the crate has a mass of 800 pounds. Okay, or you just can use the weight of 800 pound force like that. And the one in question is this one, AB. Okay, the force which is happening at link AB. How can we solve for this? As usual, where we're supposed to start?
We should know the two force member first.
Just correct. Actually, before that, you're supposed to understand the problem, and you did, okay? And now the second one is to find out which one is the two force member. How many two force member that you can find here?
3, I guess.
3. What are those?
A, B, C, E, E, D.
A, B, C, E, E, D. Yes, you are correct. Those three are the two force member. And what we're supposed to do to those three two force member?
Find the force.
No, not find the force, but in the free body diagram, what we're supposed to do for those three two force member?
What do you mean?
So you know that we have three two force member, right? And
Yes.
the basic thing behind finding out the two force member is to simplify the calculation. So why in the frame and machine we have to find out the two force member first is because we need to simplify the calculation, and we can simplify it by finding force member and replacing it with external force.
Yes.
At the same direction as the member. Correct? Right?
Yeah. Yes.
Yeah. So
make a separate free body diagram.
Separate free body diagram for which one?
Anything. CBG or DAF.
Free. We have free there. What? C or CBG or DAF. Okay. CBG.
Yes.
Okay. Which one that you want to draw then? You prefer which one?
CBG.
Well,
yeah, CBG.
Both will give the same actually. So
yeah.
CBG. Okay, so this is it. CBG. Okay. That.
Yes.
Okay, so let me put the point here. This is point B. That's right. Yeah, that's point B. This is point C. Yeah, and it's G here. At C, what is happening at C?
External force CE.
CE, and do you know the direction?
Just make it outside tension.
Okay, so the line of action is supposed to be like this, right? So you okay, we can assume tension or compression. Actually, it's quite free. It's up to you. So now we assume it as tension as C. F C E. What else? At B. Then.
AB. Yeah, friction at
AB.
G.
Okay,
AB.
AB here. Okay, assume you want to assume it as tension or compression.
Tension also.
Tension as well. Okay, it's okay. We put it high.
I think yours.
Yep. Sorry, I just. Okay, at B tension as well. So going to the left, right? Tension.
Yes.
FEB. What else?
Friction at G.
Friction at G. The friction force is supposed to be going to what direction?
Upside.
Upside. Up. Up. It's supposed to be the one at the crate, right? If we draw it at the crate, yes, it will be friction force going up. And the normal force is going like this, right? So for this one, it's supposed to be the opposite, right?
Yeah.
So it's supposed to be going
down.
Going down, right? And there will be a normal force as well, of course, because without normal force, there will be no friction force. So it's supposed to be like this, right?
Yes.
Okay. So this is our GX, and this is our GY.
Yes.
Okay, but how can we solve it?
We can solve GY from the crane
Ah,
body
okay,
diagram.
from here. So here there is a 800 lbf. Then we have a GY. Okay, and because of it's symmetric like this, right?
Yes.
Because it's symmetric, this one is supposed to be GY as well, right?
Yes.
And this one is supposed to be GX and GX as well, right?
Yes.
Okay. How can we get it? What
From
is the value
sigma
of
Fy.
sigma Fy equal to 0? What you have it?
Yes. 2GY equals 800.
So GY is equal to 400 lbf.
Yes.
Now can we solve it?
Mm. Hmm. Using moment.
Yeah, but can we solve this particular problem now?
Yes.
Yes, of
Should
course we
be.
can, because we have 3 unknowns.
Yeah.
Okay, and we have 3 equations. Sigma fx equal to 0. Yeah. Sigma fy equal to 0. And sigma moment equal to 0.
Yes.
Okay. And you can start using sigma fy equal to 0. Okay. Using sigma fy equal to 0, what you will have is if going down is positive, if going up is positive is FCE cos theta here, right?
Yes.
Theta there, tangent theta is supposed to be, what is tangent theta there?
Wait, sir.
This one theta.
Oh yeah. 80. 12/18.
Yes, correct. 12/18 of, yeah,
2/3.
2 over, oh yeah, correct, 2/3. 2/3. Tangent theta we got, and the tangent theta, okay. FCE, now we need the y direction, so FCE sin theta, right?
Yes.
Okay, then what? Our sigma Fy equal to 0.
0.
FCE sin theta minus
GY.
400, right? Okay, in this case,
400.
is equal to 0. So we get FCE. Okay, so you will be able to find FCE. And after you find FCE, then which equation that you're supposed to use then?
Sigma moment at
Okay,
G.
sigma moment at G. Sigma moment at G equal to 0. Okay.
Yeah.
Then after that you can calculate for FAB. Yeah, FAB multiplied by what is that?
24.
So counterclockwise positive, then FAB multiplied by 24 inches. Then?
And then minus FCE cos theta.
Cos, okay,
times
cos theta. Times?
44.
Times 44, right. Equal to 0.
Plus FCE sin theta.
Oh yeah, correct. FCE sin theta. Plus, minus, correct. Then it's going up. It's going up.
I mean minus.
Minus, right? It's not positive, right? It's supposed to be minus.
Yeah.
Yeah, because it's counterclockwise. So minus FCE sin theta multiplied by
Is it 27? Because
18,
it's not-
18, 30. 18 plus 18 is 36, and the grade is 30. So the distance, the horizontal distance here is supposed to be 18 minus 15. So it's supposed to be 3 here.
3,
Correct, right?
yes, 21.
Okay, so 18 plus, why is that 21? No. You are not. Okay. 36 minus 3. That's the answer.
33.
You understand why 33?
Yes.
Okay.
Yeah.
Multiply by 33, which is equal.
Should it be 30 because 36 minus 30?
36 minus 30. Yeah, no,
I mean 36
this one
minus
is
6.
30.
Yeah.
This one is 3. And this one, the distance here is 3 as well.
Yes.
But the one that you want to find is the horizontal distance between this and this, right?
Yes.
So it's actually basically is from here to this one, right?
Is it not from B?
You are doing sigma moment at G, right?
Oh, yeah. I forgot.
You are doing sigma moment at G. Why suddenly you move it there? So it's supposed to be 36 minus 3. So it's supposed to be 33. Just
Oh, yeah.
okay. So by doing so, because CE is, you find it from the previous calculation, then you will be able to find FAB, right?
Yes.
Okay, so FAB will be found. That's the way to calculate.
Yes.
Okay, thank you, Michelle.
Yes, sir.
Okay, anyone having a problem in this particular question? Awas. Is there any problem for us? Risky. Why Risky is so quiet today? Don't say that you sleep again. Huh?
His back is hurting. He cannot
Hello,
get
what?
up from bed.
Back. You have a back problem. Risky?
Yes, hello.
Yeah. Do you have a back problem, Risky?
Yeah, I have a baggage for the last 1 week.
What happened? Did you play basketball? Or what?
I don't really know.
Oh, or you sleep too much?
I don't know.
Oh yeah. In this particular work from home, school from home, I think I need to remind you guys. You need to keep training your muscle, because if you sit too much or you sleep too much, right? Your muscle become lazy, and sometimes it can cause those kind of problem, back problem, or sometimes in the or your hip as well, because it happens to me. It happens to me like several months ago, and it hurts so much. And then after that, after I go for the physiotherapist, right? And then after I finish going there, everything fixed, then I start exercising again, and now everything is getting better. Okay, Risky. Okay.
Okay, Pak.
Sir, I have a question.
Yeah.
From where we get 33 in FCE sinus 30.
Sorry, I don't get it.
From where we get 33 in equation the FCE sinus 33.
FCE sinus theta multiplied by 33 inches like that. Why we get 30?
Yes, sir.
33. Okay. So it's
Yes,
basically like this. You can see, right? The distance, the width of the crate is 30 inches, right? Correct or not?
Yes, sir.
And then from C to D, the width there is 18 inches plus 18 inches, right?
Correct, sir.
So from C to D, the horizontal distance will be 36, right?
Yes.
Okay, and because it's symmetric, okay, the if C from C to D is 36 inches, and from F to G is 30 inches, okay, you can see, right, the horizontal distance from C to F is supposed to be 3 inches, right?
Correct, sir.
And from D to G is supposed to be 3 inches as well. The horizontal distance, right?
Correct, sir.
Now, I want to find the horizontal distance between C to G. Lalu,
Yes.
okay, the horizontal distance between C to G is supposed to be 36 minus 3, right? Because it's the same as C to D, then minus D to G, right? The horizontal distance there. So it's 36 minus 3, so 33. Correct, right?
Okay.
Yeah, that's 33 inches come from. Okay, any other question?
Sir.
Who's this? Adam, yeah.
Instead of using sigma m, are we allowed to use sigma fx?
Yes, of course. Any equations between sigma
because it just
fy,
looks easier. Yeah.
sigma fx, sigma moment is okay. But if you use sigma fx, right, in this particular free body diagram, if you use sigma fx in this particular free body diagram, okay, the not yet solved free body diagram, then you will not be able to find the value that you want from the beginning, because all the components, all the variables that gx, fab, fce have x components. So there will be 3 variables in one equation. So you cannot solve it directly. That's why from the beginning, I try to solve it using the sigma fy. Why sigma fy? Because this gy has 400 lbf has a y direction, and fce has y direction component as well. That's all. So I will be able to find fce directly from sigma fy. Then why I go for the sigma moment at G? Because the one in question is fab, right? If I do sigma moment at G, okay, fce is known at that time because I solved sigma fy already. Then I can find fab. I can find fab from sigma moment at G. Correct, right?
Yeah.
That's the logic behind that.
Thank you.
Okay, I think I will continue again with the next one. This one, or this one, or just that one. Be the same. It will be your homework. I think it will be this way. Yeah. Okay. Okay, I think let's do this particular problem. I think each of you, please try to understand this particular problem. This particular problem will be our last problem for today. And the rest, I will put it in your homework. And next week, we will start, remember, okay, next week, we will start our class with a quiz. Then after that, I will continue the discussion on the homework as well. Hey, closing. Why is closing? Yeah. Okay, let's try to this. Okay, please, all of you try to read it carefully, and we will try to do it together. Michelle, would you mind to point out one of your friend here to help me to do this?
Anyone, sir?
Anyone? It's up to you.
Okay, sir, let me think. Faiz.
Okay, Faiz. Hello, Faiz.
Oh. I think there are two Faiz.
Which Faiz then? Hello, Michelle. Which Faiz?
Faiz Setia.
Faiz Setia. Okay, Faiz Setia. Please help me to do this, Faiz. Hello, Faiz.
Hello, sir. I'm sorry, my connection is too bad.
It's okay. I can hear you clearly. Okay. Help me to do this, Faiz. Do you understand the problem, Faiz?
I still think so.
Okay. The rest of the class, please try to understand it as well.
We should state the two first members, sir.
Oh, yes, of course, we're supposed to start with that. But before that, okay, the first step is to understand the problem. After you understand the problem, then yes, try to state that, try to find out the two first member in order to simplify the problem. Okay, fine.
Yes, sir.
The first stage first. Do you understand the problem?
I think we draw the free body diagram.
No. I mean, do you understand the problem first? Hello, Faiz.
I still hello sir. Can you hear me, sir?
Yeah, I can hear you. Do you understand the problem?
Honestly, I still really confused about this question, sir.
But you know what thing is this, right? It's a lamp.
Pardon, sir? I cannot hear you, sir.
You know what is this, right? It's a lamp, Faiz.
Yes, sir. I know.
Yeah, it's a lamp, and it's known that the mass of the lamp is 0.6 kilogram, and it has center of gravity at this particular point. That's one thing, okay? And the other thing that you're supposed to know is this one. This particular joint is joined with a friction. Okay, at point C, okay, point C is a joint with a friction, okay, joint with friction, which means that it can transmit moment as well. But the other joint, A, F, B, D, those joints are frictionless. Okay, so now the question is, the spring force Fs to create equilibrium condition like in the picture. The spring force is this one, from A to E, that spring. Okay, so that is the question. Is it quite clear, Faiz?
Yes, sir.
Okay, now, if you understand the problem, now we go to the next stage. Find the two force member there. There are a lot of two force member. Try to help me to find the force member. Hello, Faiz?
Hello, sir.
Yeah, can you help me to find the force member?
At BD, AB.
BD, correct. BD is two force member. AB is correct, two force member as well. What else?
AB, BC.
BC, CD, it's those two are in question. Later I will discuss about it. How about AE, guys? The spring AE is two force member or?
I think yes, sir.
Yes, of course. Spring can only either under tension or under compression, right?
Right, sir.
Yeah, so AE is two force member as well. So those three you have to treat it as two force member. BC and CD, this is for all of you guys. Okay, BC and CD, it looks like it two force member. Those two are two force member. It looks like those two are two force member, but actually those two are not two force member. Those two are not two force member. Why? Because as I told you from the beginning, C here is a joined with friction. If it's joined with friction, means that it can give moment there. The moment will appear there. When the moment will appear there, the member which join at that particular joint will not be two force member anymore. Because one of the definition of a two force member, right? They must be joined with a frictionless joint. Because two force member will not allow moment given to one of its head. So BC and CD is not BC and CD are not two force member. Do you understand about it first?
Sorry, sir. I can hear you, sir. My connection is too bad. Hello, sir.
Okay.
Hello.
So basically, C is joined with a friction vice, because joined with friction, so it will give a moment there. Okay, if moment happen at one particular
yes, sir.
ends, that member will not be a two-force member anymore. So BC and CD are not two-force member. Okay, you get it?
Pak,
Yes,
I want to
I
ask
get it,
something,
sir.
Pak.
Yes, Rizky.
So if there's no friction in C, BC and DC can be two-force member.
Yes, correct. If there is no friction at C, okay,
Thank you, Pak.
BC and CD will be two-force member. But the problem in that particular case, the lamp will go down. It will fall. Risky. So the purpose of putting C as a friction, as a joint with friction, is to hold the lamp. Do you get it, Risky? Okay.
Yes,
So,
I get it, Pak.
Now I will continue. Okay, thank you, Faiz. Seems like Faiz having a bad connection. So for this one, I think I will try to show you guys how to solve it. Okay. So at C, there is a joint with friction. So there will be a moment there. Okay. So how can we do this particular free body diagram? Okay. Then remember that the one in question is just FAE, which is the force which is happening at the spring. Only the force which is happening at the spring. Okay, how can we handle this? Okay, how can we handle this? So the easiest way, as always, is try to solve for the non-two-force member, okay, the multi-force member, create free body diagram for the multi-force member, and assume and then replace the two-force member with an extra force. So for these particular things, okay, the easiest way to solve it is to solve for FED. Okay, we can solve for FED. Okay, at FED, okay, FED is non-two-force member. So at F star, it will be Fy and Fx due to join F here. Okay, at point E, there will be force due to AE, the spring AE, like this. This one is FAE. What else? Then at point D there will be external force as well. Okay, external force due to join D there. So there will be dy and dx. But by doing so, we can see, right, in this particular free body diagram, we have 5 unknowns. We cannot solve it. We cannot solve it. So how can we solve it? Then we have to solve for another free body diagram. Okay, another free body diagram. Okay, the other free body diagram that I want to solve is this particular system. BDCG, those together. Okay, those together. I assume those as one system. So this is what I will draw. Okay, so I will draw the lamp and some of the member there.
Sir, is AB and BC two different members?
A, B, and BC. Sorry.
Yeah. Is it just one member or?
Oh, no. A, B, and BC are two separate members. Those two are two separate members. There is a slight angle there, so it's two separate members. Okay, Matthew.
Okay.
Then I will continue here. At G here, there will be a force 0.6 kilogram multiplied by G, so around 6 Newton. Okay, what else that I have there? So at point D here, it will be action and reaction with this one. So there's supposed to be dx to the right, to the left, and dy going down. Okay, then at point B, okay, because P is two force member, then I will have to draw FAB there. Okay, we have FAB, we have dx, and we have dy. Okay, in this particular free body diagram, we have three unknowns: FAB, dx, dy, and we have three equations as well: sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Okay, it means that we will be able to solve for this, and this. Okay, after you solve for that, then we have dx dy, we have FAB. Dx dy, we can use it here, dx dy. In that case, this particular free body diagram, we only left with three unknowns: FAE, Fx, Fy. And we have three unknowns, three equations as well: sigma fx2 equal to 0, sigma fy2 equal to 0, and sigma moment 2 equal to 0. So we will be able to solve for these three. That's the way to solve it, guys. Okay, because we don't have time to calculate for it directly until the values, right? I will leave it to you guys. So this will be your number one homework. So later I will put this as your number one homework, and this will be your homework as well, and this one will be your homework as well, this one as well. Okay, some of those will become your homework. Okay, remember that next week on Thursday, we will have a quiz at 10 a.m. Okay, we will start the quiz at 10 a.m. Okay, so please be prepared. Okay, any question about this? Any question? if there is no question, then I think that's all for today, because it's already night. Yeah. Hello? Irfan?
Yesterday, I think I forgot my to take my absence in 6:30.
I think I will join everything next week. Okay, Irfan. So Thursday next week. After the quiz, please remind me to fix the fix the attendance. Okay, Irfan? In the
Yes, sir.
middle of the
Thank you.
sorry, at the beginning of the class, after the quiz, at the beginning of the class, then remind me about it. And for everyone else here who have a problem with their attendance, okay, whenever it is, okay, let me know that. Okay, Irfan,
Yes,
is it
sir.
clear,
Thank
Irfan?
you.
Yeah. Okay. If there is no more question about this, then I think I will conclude today's class. That's all for today's, guys. Thank you for listening, and don't forget to check the MS Team for the homework. Okay, and see you guys on next Thursday. Okay, see you guys.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.
Thank you, sir.